Right, this video is about working with identity questions, which is the left-hand side versus right-hand side type questions. This is where they say prove the following, or prove that something equals something, or show that the left equals the right. In this case, you need to know your rules. So if we have a look on this page, we have our identity rules. Tan is equal to sine over cos of the same angle. Tan squared of an angle is equal to sine squared over cos squared of an angle. Sine squared theta plus cos squared theta equals 1. So you can rearrange that by taking the cos squared over and making it 1 minus cos squared theta will give you sine squared theta. Or cos squared theta is equal to 1 minus sine squared theta. Now theta is just representing the angle. They could use an x, they could use an alpha, a beta. It's whatever angle is missing in the question. Now again, in these you are not solving for the angle. You are just simplifying in order to make the left look like the right. So you also would need to use your co-ratio sometimes, your cast diagram and reductions. Look for LCDs, highest common factors, trinomials. There's a lot of algebra that goes into the proving of these identities. Alright, so now in these questions you've got to separate the left and the right. You can work with left-hand side and right-hand side, but not at the same time. You'll work completely with the left-hand side or completely with the right-hand side. Manipulate until you get them to look the same. You may not take things over the equal sign from left to right. Right, so for question 1, you've got to pick the side that is more complicated. Now I know it's tempting to start on the right-hand side because you see a tan squared theta, so you can make it sine over cos. But have that in mind. Bear in mind that that's where you're going, sine squared over cos squared. Start with the more complicated side because that's where you're going to be getting the marks. Alright, the first thing you've got to do is show us which side you are working on. You cannot just start a side, you must tell me left-hand side equals. Let's have a look now what we've got. We've got 1 minus cos squared theta over 1 minus sine squared theta. Now, on the very next page, I've just pointed that out, that those are key identities. So where I see a 1 minus cos squared theta, I can make it a sine squared theta. And where I see 1 minus sine squared theta, I can make it a cos squared theta. And now if you have a look, we end up with sine over cos, which is tan squared theta. And if you see now, it's equal to our right-hand side. So you'd say, therefore, equals right-hand side. That's the end of your question. All right, for the next one, we're looking at sine squared theta, which in my brain pops out as, hang on, this is something that we've looked at. And then 1 plus tan squared theta, that's not an identity. Again, if we go to page 2, there's no identity with 1 plus tan squared theta. So we're going to come back to that. Equals to 1. So I'm going to have to start with my left-hand side here, because definitely 1 is not very complicated. So we've got to start with our more complicated side. Alright, so in my first step, I'm going to change the 1 minus sine squared theta to a cos squared theta. That's one of my identities. And I'm changing my tan squared theta to sine over cos. The idea here is I don't want a tan because the equals to 1 is probably going to come from the sine squared plus the cos squared. So we're going to try and see if we can get a sine squared and a cos squared only. So within this bracket here, we have something added to a fraction, which means we need to find an LCD. When you have something added to a fraction, find the lowest common denominator, which in this case is going to be cos squared, because that's 1 over 1 and sine squared over cos squared. So this is going to become cos squared theta plus sine squared theta, and that we know is going to be equal to 1. All over this cos squared theta. We cannot cancel, just so you know, you can't cancel that cos and that cos because there is a binomial there. So even though you think, oh, okay, cos and cos simplify, so we have a cos squared and sine squared, you are not allowed to do that at all. So now we need to think, this is cos squared over 1. So now when we're multiplying fractions, you can look at top by top, bottom by bottom, or you're allowed to cross cancel. Here we're allowed to because there's no binomial. So So if we cancel our cos's there, we're left with 1 over 1, which is just 1, which is equal to our right-hand side. All right, with number 3, I'm starting with the left-hand side. So we are working with sin x times tan x plus cos x is equal to 1 over cos x. So I've picked the left-hand side. So the first thing I'm going to do is I'm going to change that sin x to sin x over 1, and then the tan x to sin x over cos x, and then the cos x to cos x over 1, just so that you can see they are fractions. So when we're multiplying the first two fractions here, we're going to do top by top, so sin squared x over bottom by bottom. 1 times cos is just cos, and I'm adding it to cos x over 1. Now I'm going to find an LCD. Alright, so with my LCD it's cos x, so my first fraction is sin squared x over cos x. It already has the LCD, so for our second fraction here it needs the LCD, and you apply it to the top and the bottom, so we are going to be adding a cos squared x here. So sin squared plus cos squared is going to be equal to 1 over our cos x, which is our right hand side, and that's the end of the question. Alright, our second last question here is as follows. We're going to pick our left hand side again. Alright, and we're going to find an LCD because we've got two fractions added together. So our LCD here is going to be a bit of each of the fractions. So it's going to be 1 plus cos x and the sin x. We've got to incorporate both. So the first fraction doesn't have the sin x, so we need to multiply it in. So we're going to get sin squared x, and the second fraction needs the 1 plus cos x. Alright, so we're going to have to distribute that second bracket, so it's going to become cos x plus cos squared x, and then you're going to have to group the sin squared and the cos squared is going to become 1, and then you're going to have plus cos x all over sin x times by 1 plus cos x. Now I'm going to put the top in brackets, and you're going to notice that it's the same as the bracket at the bottom. So I'm going to be able to cancel the bracket at the top with the bracket at the bottom, and I'm left with my right hand side, which is 1 over sin x. Alright, for our last question, I'm actually going to start with my right hand side now, because both look quite complicated. Both have a lot going, but the right hand side then has a tan theta. So at least I know I can change that to a sine over cos. So I'm going to do that straight away. Sine theta over cos theta. Again, we have fractions being added or subtracted. So I'm going to find an LCD of sine theta cos theta. So my first fraction has the sine theta but not the cos theta. Sorry, not theta alpha. Times by then another cos alpha, because it needs the cos alpha. So then we're going to get minus sine alpha, which ends up then being sine alpha times sine alpha. So if we sort that out, a cos times a cos is a cos squared alpha minus a sine squared alpha all over sine alpha cos alpha. Now this looks like it's getting somewhere to where we need to be. We end up getting a sine alpha cos alpha at the bottom. We just need to now sort out the top. But look what's at the top. It's got 1 minus 2 sine squared alpha. At the moment, we've got a cos squared alpha minus a sine squared. So there's no cos squared on the top left, and there's 2 lots of sine squared. So let's have a look at our identities here. If we can take the cos squared away, we're going to gain ourselves another sine squared, which will get us our 2. So I'm going to make this, instead of cos squared, it's going to be 1 minus sine squared alpha minus the sine squared alpha that's there, all over my denominator. So this means we've got negative sine squared alpha minus another 1. So that's 2. Negative 2 all over our denominator, and that is our left-hand side. Alright, so grade 11s, this is the golden page for working out anything to do with identities, left-hand side, right-hand side. You must know your changeovers, you must know your algebra. A lot of it is algebraic. You often come across factorizing, trinomials, dots, so you need to make sure that you look out for those things. And when it comes to tans, look for signs of a causes. Use the other side to see where you're going to go to. You have a tan. Do I need a sine of a cos? Do I need to keep it a tan? So it takes a lot of practice, but you also do need to know your theory for this.